Okay, hello. Hello, hello, hello. Hello, is this working? Alrighty. Stream looking good. They can hear me online. The camera's working. Fantastic. There we go. Miracle. Let me turn this off. Okay, sorry, that setup took a little while. Anyway, we got there in the end. You survived week 1. How does that feel? Good? Feeling a bit more comfortable in 1511? How was your shoot last week? Good? Drew, what did you draw? Draw us. What's the activity, guys? They drew a what? Flower. And someone drew a dog, I saw. Looks good. So hopefully you're starting to settle in a little bit, which is what we'd like. It's really hot. I've got the aircon on, but if it's not cool enough, let me know. Maybe we can call HVAC or something. Cheers. Alrighty. Is this camera working? So some quick notices. Help sessions are starting earlier this term, which is really nice. If you're not familiar with the help sessions, these are our drop-in ad hoc help services available to you. So I don't think the timetable's up just quite yet. I think it's starting this week if memory serves. But if you keep an eye on the course page, I can show you if you like, but there's a section that says help sessions. You click it, there's a big timetable. You can go to any session. They run 5 days a week. And you can just go there and get 5, 10, 15-minute help with whatever problem you're facing with your COMP1511 studies. So it's a really important resource. I really, really stress and recommend that you use the help sessions. Some of them are online, some of them are in person, so they're really flexible. But when you're stuck and it's a bit too much for like a forum question, for example, like you're not getting something, help sessions are great. They're all 1511 tutors, right? They get paid some extra hours to go along to the help sessions and help you out. So keep an eye, we'll put out an announcement when those are ready. And thank you for we got 60-something lecture feedback responses last week, so that was awesome, thank you. I always like to every couple of weeks give, thank you. I like to give a little recap of some of the key themes from the lecture feedback, just to show you that I do read every single one of them, for good or for bad. So we mostly liked the lecture format and the quality, especially of the recording. Someone compared us favorably to Math 1311. So thank you, whoever that was. What was it? Oh, wrong code. Anyway, Math 1A. So yeah, screw you, maths. Some people were like, it's a little slow. Some people were like, it's a little fast. I think it's like a Goldilocks thing. Everyone's a little different, but I'll try and respond if the balance seems to tip one way or the other. You'd like the slides up a little earlier. So this week, did you see all the slides are up for this week? Yeah. Cool. And I re-uploaded last week's slides. But typos are going to happen, I'm warning you now. It's okay. It's like when we write code, we're not perfect. We just fix them up and respond, and then it's an opportunity to either discuss the mistake. But if it's a typo, it doesn't really matter. Okay. So last week you went to your tut lab for the first time. You wrote Hello World for the first time, amongst maybe some other programs as well. And then if you remember in the second lecture, we spoke about memory, reading and writing variables to the terminal, and some arithmetic. This week we're going to talk about some really important concepts. The way I think about the structure of this course is that the first, say, 6-7 weeks, each week introduces a really important new concept, a new idea that's fundamental to programming across all languages. So this week is no different. We'll be talking about control flow. Control flow and repetition are the big concepts, I would say. Logical operators is more of a tool that we have, less of a concept. But this is what we'll be talking about this week. As always, whenever I write lecture code, it's available in real time at the correct URL. It changes every week. Maybe Gab can post this in the chat if you can do that for the YouTube stream. So if you want to follow along, you can do that. I think actually in reality, this is probably better as a resource to look at after the lectures, because you're not going to be refreshing the page and getting the code. So try and follow along with me, and then later on this resource is available to you. But if you happen to fall behind in the lectures and you just want the updated copy of the code, you can grab it. Okay, so why don't we do a really quick recap of last week's content, input-output, with variables. Just to refresh everyone, have a second glance at it and to discuss it. Does that sound good? Are we all just sweating from the heat? Okay, so we have printf, a really important function. Its job is quite simple. It outputs text to the terminal. The text is what we specify it to be. And we specify that text with a string, a format string. It stands for print formatted. Even though it may not seem it, all of these weird names and things, they are an attempt at being logical. Someone is not trying to get you with these weird names. They're trying to summarize some concept, like a format print. And to access it, right, to be able to use this function, we need to include the standard input-output library. Right? So to try and be more efficient, the C programming language doesn't give you printf unless you explicitly say, hey, I'd like to include all the code that allows me to do printing, for example, or all input-output. So it's grouped in this module called standard IO. So here's 2 lines of code. Assume that you've got a main function and all of that. What's this going to print out? Welcome to COMP1511. If we think back as to how this is working, we have an integer here, so we have some memory in a variable called course code. And what this is saying is I want to put this course code value inserted into that format string, and it's going to be inserted wherever that format specifier is. That in this case, it's a %d. So this will look like welcome to COMP1511 with a new line at the end, right? And it's pretty simple. It matches the first variable to the first % whatever, right? So it's just pairing up the value and the position. Anything else to mention with this code? Oh, who remembers why it's %d? Not double, this is an integer. But that would be a logical guess. Someone else said it? Decimal integer, a base 10 integer. It's not a very nice, I know, anyway. I agree with you guys in this case. But don't forget, C was written in the 60s, and they didn't have you guys in mind, unfortunately, when they wrote this language. They were trying to be really specific for systems programmers. C was really made to sort of write operating systems and things like that. All right. Oh, here's the answer. Cool. We spoke about new lines a little bit as well. So in C, you have to be very particular with your new lines. So that first example on the left, it prints hello world, and then that's it. And then the prompt immediately follows it. If you want a new line after it, which we commonly do, you have to explicitly say, hey, I would like a new line to be inserted at this particular position. And that's the difference. You can see the difference there with those 2 examples. On this, I guess it reminds me, who read my second forum announcement last night? Did you get it? Did you get the email? Did you check your emails? Who saw it? Who saw it? Put your hand up. Okay, it is going out. Did you want to quickly talk about, I feel like maybe this is maybe a bad habit of mine, gloss over the question of why we do teach C in 1511. Does anyone, if you read the post maybe, was it convincing? Who read it? No, it wasn't convincing? Okay. We can talk about it a little bit. So sometimes people ask us, Jake, why do we teach C in Comp 1511? And there might be a few different reasons that you ask it. Is this camera tracking me? Yeah, really good job. Hopefully that's better. And there's a few reasons for it. I'll be really quick. The point is, it's fundamentals of programming. We want you to understand the fundamentals of how programming and computers work. And C is a good language to demonstrate these things. And there were some examples I put out in my announcement, so I'd recommend you go read it. But for example, in Python, printing automatically adds a new line. So it's very easy to gloss over the fact that still under the hood of Python, this is how it's working. They're just putting that new line in for you. But you don't get to see it. Whereas in C, well, that's a good, haha. In C, you get to see it, that you need to explicitly say, hey, I want a new line. And so you learn, okay, new lines, they are characters, they do this, they do that, they don't do this, they don't do that.
Maybe it's just a bias because I taught myself, but why don't we do, let's say, C++ instead of C?
C++, I mean, so one thing is that all C is C++, so, but not the other way around. C++ adds a lot of noise to the language, and it still is a lot more abstracted. So it adds features to the language to make you more productive, but not necessarily to make it better at understanding the fundamentals. We could talk more another time about it for hours. It's a hugely discussed topic. Anyway, let's keep going. Okay, so we did printing to the terminal with printf. Inversely, we can scan or read from the terminal with scanf. Pretty simple. Also comes from standard I/O, stands for scan formatted. We have to do a little bit more to use scanf, right? Because we need to have some location or some memory in order to put whatever it is that we're scanning. So this is a pretty typical example of what you would do. You would create an age integer, or whatever it is you're trying to store. You would prompt the user, you know, what are you asking them to enter? Do you remember last week we showed what happens if you don't put this prompt? It looks a bit confusing. Looks like the program just halted. And then you use scanf like this. The trick with scanf, so the %d works sort of in the way you would imagine. So what you're saying here is that I'd like to scan one decimal integer. So it's the same sort of idea as printing. So that usually doesn't trick people up too much. This can trip people up. So for now, what you need to understand is what we're saying, that the ampersand shows you where in memory we'd like to put the data. So we're saying, I want to put whatever we read in at the location where age is defined. But we're going to talk a lot more about this and why it's necessary in about week 6. For now, what you need to remember with scanf, you need to put an ampersand in front of the variable, but you don't do it with printf. Any questions on any of the last week content? I can't see the live stream chat, so if there's anything worth discussing, Gab, just yell it out. No questions? So either I did a really good job or a really shit job, right? We're just ready to move on to control flow? Give me some feedback. All right. Control flow. Anyone have an intuition as to what control flow means?
Having conditions that change the course of the code.
Yeah. So far, if you look at all our programs that we've written, there's one flow. You do this, then you do this, then you do this, then you do this, then you're done. Agreed? Create a variable, assign it a value, print it out, program's finished. A single flow. But that's not too useful. Most programs, like I imagine you open Google Chrome, and every time you open it, the exact same thing happens no matter what. It just loads, they'd probably load google.com to keep their monopoly, right? That wouldn't be very useful. All programs are dynamic, they react to input, to state, to whatever. We want to make programs that can do that too, and that's what control flow is all about. So pretty simply, sometimes we need to make decisions about what we want to do in our programs, and we can make our programs branch. It's a very fundamental topic. So that's the rough idea. What tools do we have in the language in order to achieve this? And there's actually a couple different tools, but the most important one is the if statement. And if you've done any other programming language with an asterisk, you've seen some version of an if statement, right? Python, whatever, everything. If is everywhere. So we welcome the if statement very heartily to our lives. So there's a few things to talk about with the if statement. All right. It determines the result of a true or false or a Boolean question. This is important. So if the weather is greater than 20, right, wear a t-shirt. That's a yes or no question. Agreed? If it's raining, bring an umbrella. Yes or no question. So our if statements are always yes or no questions. Always. If the result is true, we can specify a certain set of instructions that we want to complete. but only if the question's result is true. So only if it's raining do we go about doing the rain activities. You know, put on a jacket, get your umbrella, take the clothes inside, and then you can go off and do the rest of your program. So for example, if I've got an integer called x, if x is even, I can do something to it, but only if it's even. Any questions on just this as an idea, as a concept? Is it kind of making sense? I'm seeing some nods. I'll take that as a yes. Okay, so how do we ask yes or no questions in C in our programs? So we have this idea of true or false. And in C, interestingly, right, we've said this, C is a very simple language. There is actually no data type or structure that represents true or false. It's just an integer that if it's 1, it's true. If it's 0, it's false. Later versions of C, and if you've done C++ and many languages after, actually do add a Boolean data type, but I don't think we really... You can use it, but we don't worry too much about it. So it's really simple. But the key actually is that you can use the term TRUE and FALSE. You can type out true or false, but all it means is 1 or 0. So how do we write an if statement? What's the syntax, right? So what do you actually type into your code editor to do these tasks? And so here it is here. And remember we said that anytime you have angle brackets in my syntax examples, that's where you have to put your own sort of code. But let's look at the overall syntax. I can say if, open some brackets, these two, some condition. So this could be like if it's raining, right? Or if x is greater than 5. Whatever our condition is. Then only the code within this block, remember we said braces are blocks? They're groups of code. Only the code within that block executes. Only if the condition returned a 1. Remember? True. So it requires a condition, it executes the block if it's true. That condition can be anything that evaluates to a true or false, or a 1 or a 0. So here's an incredibly stupid but valid and simple if statement. If 1, we have this printf statement. So let's think about it. What's this going to do? Who thinks it's going to print the condition was true? Who thinks it's not going to print the condition is true? And everyone else, what do you think? So come on, okay, I'm forcing you to pick one answer, right? So who thinks this will print the condition was true? Everyone, okay, yep. And who thinks it won't? It's fine if you, okay. So remember we said, true is 1. 1 is true. They are the same thing. So 1 is going to evaluate to true, or 1 is true. Therefore, this block will execute. So it will print out, it won't print out anything. That whole block will be skipped over.
So if you decide to write true instead of 1, do you need to include some kind of library?
Okay, so the question was, if I want to use the word true there, instead of 1, do I have to do something? And here's actually example number 2, which is exactly what you're asking. What about this? What's this going to do? Will this print anything? Who thinks it will print something? And who thinks it won't? And everyone else? Come on, these are the foundations, guys. These are yes or no questions. Everyone's got to put their hand up. Okay, this won't print anything, and you don't have to include anything in this case. So this true or false is very simply mapped to 1 or 0 automatically, and you don't need to include anything. I think, actually, to get technical, in very, very early versions of C, this wasn't possible. In the version of C, languages evolve over time. The C99, for example, and then later versions. This label was introduced, but it's just a little label. All right, here's a little teaser for what's coming. Now, we haven't explained what those weird sequence of characters are, but you might be able to just intuit it. So who thinks this will print something? Look at that. And who thinks it won't? Very good. So these are valid if statements, but they're not questions. There's just, if true is always going to be true. If false is always going to be false. We want to ask questions. How do we ask yes or no questions? How do we ask Boolean questions in C? Well, the answer is we use special operators. And here is one such operator. This is greater than or equal. So what this is saying is, if the thing on the left is greater than or equal to the thing on the right, what's it going to return? True. It's simple. Now, you do have to learn that characters means greater than or equal to, but if you learn what that means, you'll be fine. And this is cool because it's an actual expression. This is not true or false, right? It's an expression. It's a question that will evaluate to either true or false. So when this line of code runs, what actually happens is that the program gets to if. It goes, okay, I've got a question that's going to be asked. Is x greater than or equal to 0? So it has to do a few things. It's got, okay, what's the value of x? Well, x is 5. Is 5 greater than or equal to 0? Yes, return true. Then it's saying if true, goes off to do its thing. So it always gets evaluated to something like this, or this. I mean, we already answered. So wait, what is this? And are there other ones that we can use? And here are our handy little list. And I think, fortunately, they're pretty logical, right? Less than, greater than. Less than or equal to, greater than or equal to, is equal to. Do you remember last week we had a single equal operator meant assignment, and I said you're going to get it confused with equivalence? Well, this is equivalence. Is the thing on the left equal to the thing on the right? And not equal to. These are pretty standard mathematical, right? It's common to use an exclamation mark to mean not. But what do they all have in common? Well, they all have in common that they evaluate to either true or false. Any questions? Pretty straightforward? Or, well, maybe not straightforward, but are we comfortable so far? Yep. And online's going good? Oh yeah, here's another. You might be thinking, Jay, come on, we're not that bad. Seriously, I see this all the time. And I do it myself. Well, maybe not now, but I did it myself plenty of times. So it's a shame because they look so similar, but they're totally different things. One's doing equivalency, one's doing assignment. Totally different things. In fact, I've seen really surprising real-world bugs caused by this in industry, like in real software projects with experienced software developers. They're edge cases, they don't come up often, but every now and then someone does an assignment, but the assignment returns true or false, so it looks like an equivalency, and then there's some massive problem down the line. So it actually comes up. Oh, if I'm stressing something, just as a little note, it's because I've seen it, not just with students, but it even pops up in industry all the time. All right, let's do some activities. Let's do them a little rapid fire. So question 1, who thinks true? Who thinks false? Okay, very good. Question 2, true? Yeah, okay, too easy. What about 3? True, okay. Maybe just yell it. Can we just yell it? 4? True. 5? 6. Yeah, it's correct. It's true. Remember, if you were paying attention, what are characters in C? They're integers. So this is saying, who's got a really good memory? What's the ASCII code for capital A? 60-something. 65. So what this is really saying is 65 different from 66? Which is obviously true. But what's cool is, I think this is actually a really good way of demonstrating the elegance of C. Because a character is just an integer, no extra work had to go into the language to make 6 work. Does that make sense? The programmers of C, the designers of C, were very clever in making characters ints. Because they just say, well, turn it into an int and do whatever we do for ints to check if they're the same. They didn't have to code any extra steps. This is part of what makes C so fast and efficient, because it's just an integer. All right, question?
So it's A, if you change it to B minus 1, then it's
That's a great question. In fact, why don't we do that in the demo? That's a great question. And we'll pause and I'll do it in the demo. All right, who wants to write some if statements? All right, so by now, you may be becoming experts at navigating the terminal. Who's getting better with CD and code and all of that stuff? So let's do what we always do. Open up a terminal. CD into, I'm going to go into public HTML, but you go wherever you're working. I really need like a monitor stand. All right. I'm going to go to week 2. So once I get to my directory, wherever I'm going to work, and I recommend you follow along if you're doing so, I'm going to say code. Right? And you can name it whatever you like. So now we write. What's the first thing we write when we create a C file? Well, the boilerplate. Yeah, exactly. So let's do a hash include. Go away. All right, what's next? Int main. With a void there. It's hot in here, isn't it? Did maybe someone want to gab? Do you mind calling, or Hannah maybe? Do you mind calling, what is it? Estate management to see if we can get the aircon a bit. Do you mind? I don't know. Maybe Google it. Yeah. Sorry. Thanks. All right. We do this. We always put our return 0 here. Save that. And remember to save all the time, right? Alrighty. Let's do a really simple if statement. So just say if something's true. So I can say if 1, I can say printf, the if statement was true. Pretty simple, right? And so everything within that block is just the same C instructions that we've been writing. Well, it's only been a week that we've been together, but. All right, let's compile it. I'll go back to my terminal. Let me clear this. And how do we compile? DCC cf.c -out program. Some things I saw last week, some common mistakes. Not putting spaces in between the arguments correctly. So it's DCC space, your file, space, -o, space, the name of the executable. Right, don't forget the space. That works. I run it, and we get the printf statement executes.
We didn't include the stbool.
No, we don't need it for that. No. The std bool does other things. Okay, so it's not very exciting. Why don't we go back and change it? Why don't we put a 0 here? Right? Because 0 is false. So let me compile, run. We don't see anything. Should I be running this block? And it says no, and so okay, it doesn't run. This is very simple but very powerful.
What if you make like 0 equal true? Like equal true what?
Okay, that's a great question. So the question was, what if you say something like that? Is that what you mean?
Like the actual, yeah.
Like that? Standard bool. Oh, we do need standard. We do need standard bool. Never mind. Just don't worry. Choppy. I'm recording it this time so we can just re-upload the recording. I have to work on that. Anyway. Okay, so I lied. You do need to include standard bool if you want to use the keyword true or false. But you don't usually have to. You can just say 1 or 0. So actually, this is a good question. So is this going to print the statement or not? No, because it's checking is true equal to false. That is not true, so it won't run. But always keep in mind, it always has to come down to a 0 or 1 at some point, a true or false. Anyway, I'll finish that thought later. All right, why don't we do something a little more complicated? So what if we say int x is equal to 5? And then what question can we ask of? Why don't we do that? So is x, should I do it like this? Okay, good. Oops. Yeah, that was just a typo. Is x equal to 5? Why don't we just run it for completion's sake? Okay, 5 was equal to 5, so it evaluates. Did you all have a chance to write some code yourself and get it compiling? All working okay?
If you put int x is greater than or equal to 0, does that give you all positive integers? 0 to infinity?
Good question. So this is exactly how I would ask, is an integer positive? Well, you got to just decide for yourself, is 0 positive? But that's for you, not for me. Right? But that is that what you meant? No.
No. So if you put int x is greater than or equal to 5, does that make, like, does the computer now say, oh...
Don't do that.
Oh, don't.
Yeah. Don't create, are you saying, can I create the variable in the if statement?
Yeah, like the set all positive integers. Like, how do you say all positive integers?
Ask it one more time, sorry.
How do you tell the computer make a set that's all positive integers?
That's not how this sort of programming works. You've got a piece of memory, and in that memory needs to be a value. So the question was, how can I represent a set of all possible positive integers in C? There's sort of a couple ways to answer it, but the very first way to answer it is that it's just not possible. We are constrained to a very set style of programming in this language. We have a piece of memory, and a sequence of 1s or 0s has to be in that memory that represents an integer, right? A single integer. However, this is asking the question, is that integer that I've got in the set of all positive integers? Because if it's true, it's positive. I don't have a value that represents that, but I've got an expression that can tell me that.
And I'm assuming doing, like, can you make x between two integers? 4 and 5? X between 4 and 5?
Well, so if I wanted to do that, I would have to say double.
Shit example, because there's no integer between 4 and 5.
No, that's right. Yeah. But there's no simple way to do what you're saying. You'd have to just decide on the value or calculate it. Any other questions? All right, there's some more. So we want to let's touch base for a second. Who's comfortable with if statements so far? Oh, fantastic. All right, too easy. Let's make it harder. So, okay, let me go back to my example. If it's raining, let's do another example. If it's greater than 25 degrees outside, wear a t-shirt. Okay, that's my if statement. What the hell is Jake going to do if it's not true? Nothing, so I'll just go out naked, right? No, sometimes we want to ask questions, and if the answer is true, do something, and if the answer is false, do something else, right? Wear a jacket. And that's what the else statement is for. So the else statement is the best friend of the if statement. In fact, maybe not, if that's not even best friend's not the right word, it's like a parasite. Because it can only exist next to an if statement. An else statement on its own doesn't make any sense, right? Like if I wake up in the morning and say, oh, else put on a jacket, but like, what? What was the question? So sometimes we want to run a block of code if something is true, evaluates to false. So here's the syntax. So you can see this first block is unchanged from our if statement example. And we have this optional, right? You don't have to have an else statement. This optional block that says, well, okay, and if that isn't true, do this instead. That's landing okay for people? Notice I'm not asking a question. I'm not saying, there's no other Boolean question here. It's just else. And else is optional. Any questions?
Is it do something else, true, false? Like if it's true, do something. If it's false, do something else. That would be true.
So no, what this is saying is, good question. If this condition is true, do these two things in sequence. Else, just do this thing on its own. So it's whatever's in the block that's executing, if it should execute. So here's a real program, a real example. It's missing a close brace, but you got the idea. So create a negative integer called x, assign it to -5. Let me finish my sentence and then I'll ask, sorry. I don't know why I pointed at you and then told you to stop. If x is positive, so if it's greater than 0, okay, let me ask this again. What's going to print in this example? Yell it with more bravado. X is negative, because it's going to ask the question, is x positive? No, therefore the else block will run. It's pretty logical, right? Question at the front? Okay, so the question was, what happens if there's multiple if statements? The answer is, we'll talk about it soon. Good question, though. And we'll talk about it in a second. We're getting there sort of slowly. Any other questions? That's twice now. You've anticipated my next slide, both of you. Okay. We can chain multiple if statements as well. Okay, what does this mean? Jake's waking up in the morning. It's 9 a.m. on a Saturday. If the weather's greater than 15 degrees, wear a jumper. If it's greater than 20 degrees, wear a light jumper. If it's greater than 30, which is probably the case in this room right now, right, wear a t-shirt. sometimes we want to ask multiple, it's a single question, a single family of questions, but there's multiple components to it. And the way we do that is just by placing another if following from the if statement. Does this make sense? Do you want to see this in code in a real program? All right. Why don't we do the weather thing? So we can say, what's the weather today? Hey Siri, what's the weather in Sydney?
It's currently clear and 29 degrees in Sydney.
Okay, it's 29. It's probably 35 in this room. So if the weather is great, well, we can do greater than 0. We should stop talking about the weather. It's getting hotter. What is going on? We're in control. I think it turned off. If the weather is greater than 0, we can say, God, this is so slow. What's going on? Ooh. Cold. I can say if is VLab slow for others too? Or is it just me? Okay, I can't do this anymore. Give me a second. All right. Can you see that okay? So I've got a question for you all. Oh, that is really... That'll do. Is that better? Yeah. So what's this program going to print out? Who wants to answer? Okay, so who thinks getting better? Just getting better? Well, but I have a question for you. Is the weather greater than 0? So is that true or false? That's right. So all of these questions will evaluate to true except for the last one. So actually this is going to do two things. We're asking two independent questions, right? And so programming is very simple. Is 29 greater than 0? Then do this. Is 29 greater than 20? Then do this. Is 29 greater than 35? No, so don't do anything. But you can probably intuit that that's not really what I had in mind. What I really just only want to print getting better, right? So how do I do that? And that's with my else if statement. So I can say, okay, well, else, whoops. Well, actually, I probably need to swap this the other way around. But so I can chain else if like that as well. So now let's think about what this is going to do. Is 29 greater than 35? No. Right? So because that evaluates to no or false, this else will trigger. And it'll say, oh, now it's my job. It's my turn. Then we ask a second question. Is 29 greater than 20? Which it is. So we print out getting better. Now, because this is true, so now, is 29 greater than 0?
Yeah.
But is this statement going to run?
No.
Why not?
The if statement is complete.
But what made it, what did we change that made this true? It's the else. It's this else is saving the day. This else is saying I'm only going to even run this if statement if the previous thing was false. But it wasn't, it was true, so we're done. Okay, that's an interesting question. So someone just asked, what if I had a return at the end of each block? And that would achieve the same thing, but it's very messy code. Because you've got to keep track of who's returning from what. And then what if you wanted to do something after? Anyway, it would work. This is much better. All right, why don't we compile this? Now, because I just moved to my local computer, I'm not going to use DCC, but everything's exactly the same. There we go, getting better gets printed. Any questions on this? Any questions in the chat online? No? So let's say yo chat. You should have seen the streaming during COVID. I was pretty much a YouTuber. All right. Oh, okay. Let's take a break and maybe get some cold air / a drink and try and cool down a bit and come back for the second half. Sound good? we back? Hello, hello, hello. Yes, we're good. Okay. Great. Thank you. Okay, so I think the room is cooling down just a little bit. Alarm. So these concepts, if, else, whatever, they're pretty simple, right? As concepts, who agrees that the idea is okay? But as you have started to notice in some of the questions at the front, you can actually get yourself into some tricky situations, right? And it's very common. I am looking at complex sequences of if statements, trying to figure out what the hell was the programmer trying to do, right? And the problem is because you can have nested if statements and joint if statements and else if, and then I have a variable, I can put data into it. Simple. In practice, the details can get us. The order of our questions matter, right? Especially with number ranges, right? Which is a common sort of style of programming, you know, trying to do something with ranges of values. You have to go from your most specific to your least specific. There's no point asking if a number is positive and then asking if a number is greater than 20. I've already asked the superset question. If I just want to run one of them, I've got to put that one first. So simple concept, you've got to really think about control flow. And the best way to think about these things is to get a pen and paper, I find, or a pencil and paper, and run through line by line, and what's this doing? What's this going to evaluate to? So what's actually going to execute? How do I get it to do what I want? So this is generally good advice with programming, okay? I'm guilty of this. I feel like everyone's guilty of this if you've done programming before. Sometimes we end up like banging our head against the wall and we forget what we're trying to do in the first place. Because we come across an error, we come across a bug, and we just start changing lines of code, and you're just meandering down this code. If you find yourself doing that, you've got to stop. Always ask yourself, do I know what I'm trying to do? What do I want this program to do? Okay, then you implement it. So that's just a generally piece of good advice. All right. So you said after the first part, this is too easy, Jake, let's make it a bit harder. Then I think it got a bit harder. So how are we going now? Okay-ish. Well, we're going to get a little bit harder. Not harder, but another idea. All right, this came up as well. Who asked me? And I said, I'll tell you in 5 minutes. Where are you? Anyway. Okay. What if I want to ask, is the weather between 20 and 25 degrees? How do I do that? So you might be inclined, I see this all the time, to do something weird like that. Well, it's not weird, it actually sort of makes sense, but you might be inclined to do something like that. Who thinks like, yeah, that sort of checks out? Or you could say like 20s, something like that, right? It would be nice if we could do that maybe, but that's unfortunately not the way that, I gotta turn off Copilot, that I definitely never use. I don't remember what it was now, but, oops. I don't remember what it was, but we'll figure it out later. What if I want to ask sort of a joined question in one statement? And there's actually 3 ways of doing this. So here's some new concepts, our Boolean operators. All right, Boolean operators, super important. We have the AND operator, the OR operator, and the NOT operator. So here's a program that may be very relevant to some of you. Hopefully, well, you're probably not 15, but you never know. So age is an integer assigned 15. The minimum legal drinking age in Australia is 18. How do I ask, are you between the ages of 0 and 18? So this is how I do it. We'll use the AND operator. What the AND operator does is it says, take the thing on the left and the thing on the right, and it asks the question, are they both true? Right? If you've done any sort of logic before from maths or something like that, this is a very simple concept. Are both operands true? So in this case, are they both true? Who thinks yes? It's a really tough question. So is 15 greater than 0? Let's put your hand up if you think it is. And is 15 is less than 18? Okay, then we're both true, so that will run. So this is how we can do compound questions. And then the rest of it all we do exactly what we want to do. If we're greater than 18, okay, now you're legal, else, okay, something's gone wrong there, right? If you have a negative age, something's gone wrong.
I noticed that the line you put the variable name first, then sign, then number. Is it okay if we do number, sign, then variable name?
Okay, so the question's a really good question, and I'm actually curious as to why you asked it. But the question was, can I swap the literal integer and the variable? And the answer is absolutely. So I could say is 0. So we don't naturally. I think we don't naturally think in this way, and that's why we don't do it. But I can say is 0 less than age. No, it's not a style issue. I think it's purely that we more think naturally like this. However, actually, some software engineers think that your idea is superior. And does anyone know why? If you know why, I will give you a Tim Tam or something from my bag. Who thinks they might know why? So why might it be better to put the literal value on the left side of the operands? It's actually not for this operand that we care about. It's more like it's more for the equivalence operator.
So it looks more like inequality, like 0 less than age less than 18.
No, it's weirder than that. For maintainability? Readability, no, it's probably less readable. You want one more guess, and I'll show you? No, it's even simpler than that. What about online? Is anyone saying it online? Here's two if statements. So no one's getting a Tim Tam, it looks like. Not yet, at least. Here's two if statements. What did I say is a really common bug?
What if it interprets the 0 as false?
Forget that it's 0. It could be anything. What did I say some people do all the time? They make these assignment. Now, let's say I make this bug. Which of these two lines is going to have an error? The second one. We can't do that. And that's actually better, because the fact that this doesn't work means that I know I made a mistake. Now, this is like pretty serious software engineering. If you're thinking this far ahead, you're writing some pretty secure code. I think it's fascinating, because what you're trying to say here is that I'm expecting a future programmer who's not as good as me, not as good as all of you, might come along and try and modify this and make a typo. And if I code like this, it's slightly safer. I don't know, maybe it'll save you 1 time in a million. But if it does, and you're writing really secure code, you're sending people to the moon, literally, it doesn't hurt, right? It doesn't cost us anything. Anyway, that's a little fun fact. You don't have to worry about it though. You can do whatever. You're not sending people to the moon just yet. So if you come across a bug like that, you'll just fix it. But it's, anyway, interesting question that you might not have thought about the full extent of it. But in general, we think, I think personally more like this. Is my age greater than 0? I'm actually struggling. What is it? It would be 0. Is 0 less than, yeah, it'd be, is 0 less than age? You've got to swap both the order and the symbol.
What about if your age is 18 and your code doesn't cover that age?
Yeah, good point. It should be equals to and greater than 18. Yeah. Let's make a all right. What shall we write? What's a nice idea for a program? Give me some ideas. Anyone got an idea for a context? Done legal drinking age. What's going on in pop culture at the moment?
I think we can use the earlier idea, but instead we can scan the age.
We can definitely, that's a great idea, but I always get stuck on like, what are we writing about?
Using scanner.
Yeah, that's something we'll do, but what are we doing? Drinking age? Are we doing weather? Give me another idea.
Speed limit.
Speed limit? Yeah, we could do speed limit. Grades? Grades is another good one. Let's do grades. What? Go away. All right. Okay, let's do grades. Are WAMs integers or floats? They're floats, right? Your WAM? Yes? Whoops. Oh no, we said we'd read it in, right? So, what did I do? You saw nothing. Float would work, but anyway. How do we read in a double from the terminal? Yell it out. What are you saying? LS. LF. Oh no, no, scanf. Yeah, let's start. Yeah, okay, gotcha. All right, just tell me what's the type. What did we miss first? The prompt. Or never forget the prompt. Percent what? LF for a long float, which is a double. And what am I scanning into? Ampersand WAM. Exactly. I'm scanning a long float or a double into WAM, ampersand WAM. Doesn't sound like an English sentence, does it? Anyway. So now I read in a floating point from the user. Okay, here's another little tip when you're writing code. And these tips, if I point them out like this, I don't care that you're in your second week of your first programming course or if you're in your final week of your final programming course, these tips are always useful. Anyone guess what I'm about to say? Maybe not. Always run, test, compile your programs in small blocks. Even though I'm pretty confident this is valid, why don't we compile it now and just make sure? So that when you've got 40 lines of code, 50 lines of code, 1,000 lines of code, you don't get overwhelmed. So one tip, write this down. It's really important for success. Test, compile, run your code iteratively. Oh, I need to... All right. All right, ask me what's my WAM. Let's say I got a 4.0 because I'm a brilliant student. All right, it looks like it's all right so far. At least there's no compiler error, we know that. Oh wait, I'm thinking GPA.
Yes.
There you go, joke's on me. What's WAM out of? I do know that, by the way. Maybe. Oh, I have a great idea for this program. You've just inspired me, everyone. We'll turn WAMs into GPAs. So if you're going off to, who wants to do like exchange at some point in their degree? Go to the States? Anyone want to go? Well, if you go to any GPA university, someone will have to convert your WAM to a GPA. So we can make a program to do it. Cool. All right, I'm inspired. All right, we've read in a WAM from the UNSW student. What's the first thing that we want to do? Okay, well, sounds like we're not sure. So, and I think one reason we might not be sure is because there's a few different things we can do. So why don't we plan out our program? First of all, we actually need to learn or figure out how we convert WAM to GPA. For our case, let's just come up with a really simple interpretation, but it may not be true. But we'll say if it's 0 to 25, it's a 1.0. If it's we can say else. Right, something like this. So I'm just using comments, but what I'm trying to do here is plan out what should my program do. And if you're paying attention, you should spot that this is not very good planning. Exactly right, exactly right. So someone just pointed out, well, I mean, what happens at, okay. Let's keep the noise down a little bit. Let's look at this plan. What happens if your WAM is 50 on the dot? What's your GPA? So I didn't plan this through, and you can think that if you just started writing code, you'll start coming across these edge cases and then you're in trouble.
Can't you simplify it by dividing by 100 times it by 4?
Well, that assumes that that's how it works, because you might get a 3.4, but maybe we just need to map directly to a single 0.0, which anyway, yeah, if that's your business case, you could do that, but we're trying to teach if statements. So we could do that at the end, convert it in. So an easier thing to say is maybe it's something like this, right? Right? That looks like a bit better of a plan to me. Does anyone else spot any issues with it or have any other suggestions? 49.5. What if it's 49.5? That's a great question. So we're doing floats, doubles. We're going to have to think about rounding.
We can do
Yeah, yes, but yeah. When we actually turn into code, we'll do that. I'm just thinking out sort of comments. This is more pseudocode than code. I love that. That's a great, what's your name? Caitlin? Aaron? It's hard to hear anything. I'll give you a chocolate or something if you want to come up later. What did you say again? What happens if it's an invalid number? We always have to think about this. What happens if they type in -50? What are we going to do? Well, so that means we have to program in the edge case. So we might say if negative, invalid. Maybe we ask them again or something.
And if above 100?
And maybe if it's above 100, although, and this is where, right, I mean, absolutely valid. And then you go off and you work in industry, you start writing code, and then you find out, oh no, worms can go above 100 because they got a bonus mark for this, and that, and then weird edge cases come up. But absolutely, if above 100, let's just say it's invalid. I think that's a good enough place to start writing some code. Sorry? Oh, okay. Yeah, well, okay. Yeah, all right. So not a number. We have to deal with that too. I love it. All right, let's start writing some code. Now, there's different ways to approach this. If you just started writing some code, you might write something different to me. I'm going to do this the way I would do it. Maybe it's not the best way, but it's a way, and you can evaluate that for yourself. Something I like to think about is to handle the invalid cases first. The reason I think it's a nice way to do it is because you're not letting the garbage into your house at all, if that sort of makes sense. Don't get to my logic. Let's just gatekeep. So we don't like to gatekeep in our social lives, but in our programming lives, go for it. Gatekeep. So what are the invalid states if it's negative? So what do I want to do here? I have a question to ask. What's the question? If wham is negative, something like that. Now 0 is valid, so we just want less than 0. Now I could do this and say, I could say printf invalid. And then I also want to check if it's greater than 100. So I could put another if statement in, or what could I do? And statement, absolutely. And the wham is greater than 100. Great question. So that's not possible. This statement's not possible. So either I could do the inverse, or what could I do? Use or, absolutely. So what or asks is the thing on the left or the thing on the right true? So if either one of these is true, we're gatekeeping. Right? In fact, we could gatekeep so hard that we can just return here. To say, no, I'm not even going to allow this to continue. I don't mind that in this case. But you don't want to get too liberal with your returns. Like 1 per block is probably okay.
Are they able to make the program retry and then?
Absolutely. Maybe we'll do that as a stretch goal at the end.
Okay.
Yeah, absolutely. But that is something you'll be doing in the course for sure. The question was, can we give the user a chance to retry? But in this case, they could also just rerun the program, but we'll do that. All right, so we're handling handle invalid cases. We won't check that it's not a number yet, because that's a little bit more complicated. For now, we'll just assume that it's a valid double. Alrighty, what's next? Now, okay, so we said else if. Interestingly, I could actually just do an if here. Because there was a return here, it's actually the same thing, but else if is good. And what's the question? So we could do from 0 to 24, and I think that's completely fine. So what's the actual question? What am I typing here? Don't start. If wham is what? Greater than or equal to 0. Yeah, very good. Very good.
To handle the edge case of if your WAM is 24.5, why don't you just do it's less than 25 and then the next one less than or greater than or equal to 25. So one's inclusive of 25 and the other's not inclusive.
So that, let's fix it at the end. Let's fix it at the end. Let's not overcomplicate it too much, but it's good that you're thinking about it. All right, what's next? And we just do another one. In fact, why don't we just copy it and update the numbers? So this would be 25, the minimum, and 49. What's a message for 2.0?
Just leave us right.
Rect? No. Ish. What's next? And finally? Who said else? Was that you? Yeah, we could actually just do an else here. Why can we just do an else?
Because you invalidate all the...
We've done everything else. We've done negative, we've done above 100, we've done everything up to 74. So all that's left is the rest anyway. Perhaps you could argue that adding the checks in is slightly better, but I think this is fine. It's like a Tiger program. High standards, yeah. Yeah, shall we run this?
Return to me.
That should be at the end. Yep. All right, give me a number.
4. 9.
Cool. There you go. You can see that with control flow, we start to be able to do useful things. Do you see that? Up until now, cool, yes. Useful, maybe. But this is getting cool, useful. Now, something when you're doing things like this, you got to start thinking about edge cases. What was one of the edge cases? So what if I have 49.1? Is that right? So what's that going to do? There you go. Something's wrong there. Because we're comparing... Why would that do that? 49.1.
Because it's an else case. It's an else case. It passed everything. It's true.
So 49.1 is between... So it's not in this, and it's not in this. Right? So this is where you've got to be careful, especially with floats. Now, there's a couple ways you can solve it. A really simple way is to turn these into floats. That's probably the simplest way.
You should change that.
Yeah, something like that. But I'll leave that exercise to you to think about.
We should change the WAM as 49 and 49 that will be less than 50.
Yeah, that's what we're doing. Yeah, that's one way of solving it. Another way could be to just turn it into an integer. Another way could be, probably this is the best, or to turn these into floats. So, in fact, that should probably be like that. So if you're dealing with floats, keep your checks as floats. Do we want to quickly fix it? Is that right? Oh, less than. Yeah. What, but we should do. That's fine, like that.
Should the second one be just less than?
Yep. Let's try that quickly. Was it 49.9? Yeah, that's good. So, but this is more of a double issue than a if statement issue. But it's a gotcha for sure. Any questions? We'll talk more about validation and checking that it's a floating point in a future lecture. All right, we've got 20 minutes and we've got another interesting topic. Repetition. It is actually a form of control flow, okay? But it's a control flow that's not doing branching, it's doing repetition. But it's super useful. Programmers are lazy, we don't like repeating ourselves, especially not in code. How can we make computers do that hard work? Computers work really fast, let's utilize that. Just some real world examples. If you're reading a recipe to make a cake, it doesn't have an instruction for each time you need to stir the cake mix, right? Imagine if it said stir, 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 stir. That would be pretty useless. You just say stir for a minute, right? And this is the same idea. The way we do this is with the while statement. And the really cool thing is that if you've understood the basics of the if statement, this is super simple. It works in the exact same way. So repetitive tasks don't require repetitive code necessarily. C starts at main still and executes line by line, but we can control what's happening in that statement. Now there's three types of while loops, or loops in general. Counting, conditional, and sentinel. But let's keep it really simple to start off with. If you look at this expression, we say while expression, do this block. Does it look familiar? It's exactly the same as the if statement. You have while, you have some Boolean condition, and you have a block. The difference is, what it's saying is, while the condition is true, keep doing what's in the block. Let's do a really simple conjunctions. What's that? While true, printf. What's this going to do? Whoops. Yeah. That's it. That'll run until either like the heat death of the universe, or my laptop runs out of battery, or something like that. Yeah, sorry? Or the heat gets to us. That'll just keep running. You can't, it's sort of hard to see, but this is scrolling for ages. It's that simple and it's that powerful. We can repeat instructions in the block. And there's three different ways of using while statements. Now, there's not three different types of while statements in C. There's only one. There's just three different families of ways that we can use it to do useful things. So one of the most useful is counting. I want to do something 100 times. So it's really simple. Say, okay, what's my upper limit? In this case, it's just 5. And then I always need a variable that I'm actually counting. And we usually call it I or count or something like that. And so here's a program. What's this going to do? Let's break it down. So we have a while loop. We say, is I less than 5? So is 0 less than 5? Is that true? That means the block runs, just like an if statement. We print hey, and we add 1 to I. Now the only difference between a while statement and an if statement is one very simple difference. What's the difference?
If it's just once.
If it's just once, with a while statement, when we finish the block, we jump back and check the condition again. That's it. It's that simple. Now, because I changed to 1 now, is 1 greater than less than 5?
Yeah.
We do it again. 2, 3, 4, 5. And that's a counting loop. Let's quickly write it. I'm going to go a little fast here, but that's just for the sake of time. Let's just check that it's less than 10. In fact, why don't we print out the number itself. Oh. There you go. We print from 0 to 9. Now, something that'll get you as well, we'll talk more about this in the future. I said print 10 times, and it printed 0 to 9. So you don't actually get 10 here, unless you change your conditions. But it counted 10 times.
When you do the condition I equals I plus 1, how does it know that it's in equals in minus 1 plus 1? You know what I mean?
Say that again.
Like you've got in, and then the second I is
in
minus 1.
What do you mean
The previous i's.
Think of I as creating a new statement, and I is taking previous number plus 1.
Right, so that how does it know it's the correct the left-hand side I is the new value,
Here.
and the right-hand side is the previous one.
Yep.
Otherwise known as n minus 1, right?
I wouldn't think of it. It's not n minus 1. It's just what the. I think you're thinking of it in the mathematical world a little bit. In programming, I is a box in memory with a value in it. It starts off at 0. Is 0 less than 10? Yes. So we print out 0, right? And then we have this statement. We do the right-hand side first and assign it to the left. So what's 0 plus 1? And we assign that to 1. This now becomes a 1, and we continue. And the memory gets wiped. It's actually, your thinking is very common. And about after like 5 weeks of this, you'll forget that you ever thought that way. Any questions on the counting loop? You're getting pretty wrecked by the lecture now? Maybe? Or it's just hot, or what? How are we feeling? Okay, a couple more to go through. Don't ask me why I wrote this example. I'm not a gym guy, but I was probably just couldn't think of a program. We can have conditional loops. We're doing something until a condition is true. So in the previous example, I know how many times is this going to run? 5 times every time. How many times is a conditional loop going to run? I don't know. It's indeterminate. It's until the condition is true. Same code, same while statement, same everything, same super contributions. But we just don't, it's just a different way of using it. These jokes aren't landing. God. Or you just don't know the TV ad? Gab gets me. So here's an example. Now, you could argue it's a bad example because you could figure out this is kind of counting just in increments of 25 or 5, but it's hard to show other examples right now. But anyway, if I lift 5 kilogram dumbbells at a time and I'm trying to hit 100 kilograms lifted in total, this will loop until I've hit that target. Until that condition, the amount lifted is not less than 100. Are there questions on this? Who's feeling okay with it so far? Okay, good. And who's getting a bit iffy? It's all right. It's a long lecture, this one. All right. This is probably the most confusing out of all of them. But it might just be because the name's weird. Anyway, we call these the sentinel loops. Very similar to conditional loops, except we're manually flagging when we would like the loop to stop. So the difference is, with a sentinel loop, we have a dedicated flag variable that we can manually control that tells us when to stop looping. So rather than just bake the condition into the while statement, I can just say while the flag is not true, or while Jake has not finished lifting weights. Okay? And the key difference is we have to manually control when the flag is set to true. Now, those of you who have maybe a keen eye might be asking, not how does Jake lift 100 kilos? You might be asking, well, what's the point of this? Why not just do it like this? Is anyone thinking that? No. Maybe a little bit. Maybe now you're thinking it. It's useful. It's a little hard to explain, I think, but it's useful in the case where I might control this, but someone else might control it too. And I might leave it at that because you might be asking, what do you mean someone else? But there could be some shared resource where multiple places in your program could say, no, you need to stop looping. Thanks for the reminder. But so this is by far the least common use of the loop, I think. It's heavily used in like operating systems programming, which is probably why it's in the course. But
so basically, the use for sentinel loops is that you can give complex conditions.
Yes, that's another great use of it. In fact, that's probably a better answer. Thank you. You can also get a Tim Tam or whatever. It's where you can have very complex statements that want to set the loop to false. Another really simple example of where these are useful is, let's say you're writing a program that reads data from a CD drive, okay? So you loop while I've not read all my data, or the drive is available, because the operating system might turn the drive off, at which point you need to stop reading. So it's where you're right, it's where there's these more complex situations. Let's write one more loop program and then finish off the lecture. Conditional loops are really useful. So let's write a conditional loop. Now something else, that's fine for now, okay. This is a counting loop, super useful. I mean, if you really think about it, this is still a conditional loop. It's still a condition. Why don't we say, I have an idea. So create a limit variable, or a max maybe. Scanf. Oh, don't forget your printf. So we can read in, well, that's not a percent. We can read in an integer from the user, which is the maximum. So what would we put here? What do we put here? If you're saying it, can you say it louder? Max. So we'll loop the user's specified number of times. In this case, we can just keep it counting. Right. If I run it again, I give it a bigger number, it keeps running. And this is sort of the power of computing, right? This did 100 lines of code in a millisecond, and I wrote 4 lines of code. So repetition unlocks a lot of power for us. All right, are there any questions? Absolutely. So the question was for the assignments, exams, the labs, do we choose the loops that we do or whatever? And yeah, absolutely. But it will probably be obvious to you what you should do. And sometimes we give starter code. Okay, please give us lecture feedback in the QR code. We ask this every week. You don't have to do it. It's if you've got feedback you'd like to give. Sorry, we're packing up. Thank you all so much. I'm sorry about the heat. We'll try and call aircon for next week. And I'll see you on Friday, everyone. Thank you.